Bismillahirrahmanirrahim. Dear students of 10C, Assalamu alaikum. I am your teacher Muhammad Ilyas, and this is my fifth introduction regarding chemistry for Cambridge. I welcome you in this session, and today's topic, which is air, I have selected from your book, chapter number 14, and the topic number 10.1 according to your CIA syllabus. And the points from this topic are from A to G. So, dear students, our today's objective to understand the volume composition of gases present in dry air, which is nitrogen, oxygen, and other noble gases such as argon and carbon dioxide. Dear students, secondly, we will be focusing how we can separate these gases like oxygen, nitrogen, and the noble gases from the liquid air by fractional distillation. We will also try to understand the process of fractional distillation. Then we will be focusing on the uses of oxygen in different industries, hospitals, and we will be able to inshallah focus on the common atmospheric pollutants such as carbon monoxide, methane, nitrogen oxides, nitric oxides and nitrogen dioxides, ozone, sulfur dioxide and unburned hydrocarbons. We will also focus on the sources of these pollutants. As I mentioned earlier, the carbon monoxide, methane, nitrogen oxides, ozone, which is coming from photochemical reactions responsible for the formation of photochemical smog, sulfur dioxide, and the unburned hydrocarbons. Then we will be able to understand the reaction used in possible solutions of these pollutants. Our first focus will be the redox reactions in the catalytic converters to remove combustion pollutants from the vehicles, and then we will be able to understand the use of the calcium carbonate to reduce the effects of acid rain and in flue gas desulfurization. After this, we will be able to understand the effects of these pollutants on the health of human and on the environment of this world. The poisonous nature of the carbon monoxide and the role of the nitrogen dioxide and sulfur dioxide in the formation of acid rain and its effects on the organisms and the buildings. So these will be our objectives which we have to achieve inshallah, and for this purpose we are going to understand first the composition of the dry air. Our earth is surrounded by a layer of air called the atmosphere, and air is an important natural resource. Not only do we use oxygen in the air to breathe, we also extract other gases from the air to use as raw materials in the industries. Air is a mixture of several gases. It contains elements and the compounds that are needed by all living things. As air is a mixture, its composition varies from time to time and from place to place. So, we are going to focus on the composition of the dry air. It is containing nitrogen 78%, oxygen around about 21%, and the noble gases like argon about 0.90%, carbon dioxide 0.03%, and other gases 0.17%. The main gases in the air are nitrogen and oxygen. The rest are the noble gases and the carbon dioxide, and sometimes, if the air is not dry, the water vapors. The amount of the water vapor in the air can vary widely around the world, from almost 0% in a desert to about 5% in a tropical forest. So the composition of the air comprises of these gases which I have discussed with you. Now we are moving towards the fractional distillation of the air. Before going to understand the fractional distillation of the liquid air, we should understand what is fractional distillation. Two things are very important in this regard which I have selected for you. The fractional distillation separates a mixture into a number of different parts called the fractions. And the fractional distillation works because the different substances in the mixture have different boiling points. So I hope you have understand these 2 points, the fractional distillation. Now we are going to move towards the fractional distillation of the liquid air. The gases in the air are separated industrially by liquefaction of the air, followed by the fractional distillation. Before this can take place, the air must be free of dust, water vapors, and the carbon dioxide. Because water and carbon dioxide solidify at relatively high temperatures and would block the aperture in the apparatus used. The purified air is placed into a cycle in which it is repeatedly compressed, cooled, and allowed to expand through a tiny aperture. During the cycle, the air is compressed and its temperature increases. Heat is lost to the atmosphere. The air passes through a tiny aperture where it expands, its pressure and temperature both fall. The cooled air passes along a counter current heat exchanger where it cools the compressed air before the latter expands. Eventually, after many cycles, the air cools to the point where it becomes a liquid at minus 200 degrees centigrade. Liquid air is essentially a mixture of nitrogen, oxygen, and argon and other gases, together with the traces of other group 8 gases, less than 0.1% by volume. These gases are separated by fractional distillation on the basis of their boiling points, as I have discussed with you earlier. From this slide, you can see that this liquid air is then sent to this fractionating column, and you can see the nitrogen is collected at minus 196 degrees centigrade, argon is collected at minus 186 degrees centigrade, oxygen is collected as minus 183 degrees centigrade, krypton and xenon, these are also noble gases, these are collected almost at minus 154 degrees centigrade. So dear students, this is how we can get the different gases from the atmospheric air. Now we are going to focus on the uses of the oxygen. Here are few uses of oxygen according to your CI syllabus. The first one, the oxygen is mainly used in the industry, in the steel manufacturing. Oxygen is injected into the molten pig iron to oxidize carbon to carbon dioxide. This is how the oxygen is used as oxidizing agent in steel industries to remove the impurities. The second use of oxygen is in the welding process in the cutting of the heavy metals. Oxygen is used with the acetylene and produces a lot of heat which is enough to melt and the cut the steel. As you can see that acetylene is reacting with oxygen and producing carbon dioxide and water, and in this process a tremendous amount of heat is produced, and this heat is used, as I told you, for the cutting and the welding processes. This is sometimes called the oxyacetylene cutting because the old name of the ethine is acetylene. Now we are focusing on the third use of oxygen in the hospitals. Specifically, the oxygen tents for the kids are built up in the hospitals. What are oxygen tents? You can see from this diagram and from this illustration. An oxygen tent is a bendable piece of clear plastic held over the child's bed by a frame. The plastic is then tucked under the mattress and child can move around on his bed without having to wear an oxygen mask. This is called the tent, and this is used in the hospitals. Beside this, oxygen is used in making the many medicines, but according to your syllabus, these are the three uses of the oxygen. Now we are moving towards the some common atmospheric pollutants. Are mentioned over here according to your syllabus. The carbon monoxide, sulfur dioxide, oxides of nitrogen, nitric oxide and nitrogen dioxide, methane, ozone and unburned hydrocarbons. Now we are going to focus on the sources of these pollutants. Now we will see the different steps going on in the catalytic converter. Exhaust gases such as oxides of nitrogen, carbon monoxide and unburned hydrocarbons are the major source of air pollution. To reduce air pollution, the exhaust systems of most of the cars are now fitted with the catalytic converters. These catalytic converters have catalysts like platinum and rhodium, and when these hot exhaust gases, which contains carbon monoxide, oxides of nitrogen and unburned hydrocarbons, are passed over these catalysts, they are converted into non-harmful gases as the reactions are shown by this slide. First of all, the reduction of the oxides of nitrogen, oxides to oxygen and nitrogen. You can see the nitrogen oxides converted into oxygen and the normal nitrogen gas. And then the oxidation of the carbon monoxides to carbon dioxide. As you can see, the carbon monoxides reacts with the oxygen and convert it to carbon dioxide. And the third step is also the oxidation of unburned hydrocarbons. The unburned hydrocarbons oxidize with the oxygen and converted to carbon dioxide and water. In this way, these harmful gases are converted into non-harmful gases like nitrogen, oxygen, and carbon dioxide, which is less harmful, and basically it is used by the plants for the process of photosynthesis, so it is not going to exceed in the atmosphere its quantity of carbon dioxide. So redox reactions in the catalytic converters are very useful for reducing the pollutants from the atmosphere. Beside this, we also use the calcium carbonate to reduce the other harmful gases like the sulfur dioxide. Flue gas desulfurization, FGD, this process is very useful for reducing the sulfur dioxide from the coming out from the factories. What happened in this this process removes the sulfur dioxide from the flue gas waste gases. It consists of a wet scrubber and a reaction tower equipped with the fan that extract hot smoky stack gases from a power plant into the tower. Lime or limestone means calcium carbonate in slurry form is injected into the tower to mix with the stack gases and reacts with the sulfur dioxide present in it. These harmful gases from the atmosphere. Now we are going to focus on the effects of these pollutants, specifically the carbon monoxide, sulfur dioxide, and oxides of the nitrogen according to your syllabus. From this picture you can see that the effects of the carbon monoxides on the human health. Dear students, you can see from this slide that carbon monoxide, this is very poisonous gas and has the ability to react with the hemoglobin. Hemoglobin is present in the red blood cells in our body, and carbon monoxide reacts with the hemoglobin and form the carboxyhemoglobin. And in this way, this is going to reduce the supply of oxygen to our body, and it may lead towards different problems like unconsciousness, the body may collapse, dizziness, headache, nausea, and breathlessness, and even it may lead towards the death of the human body. So you can understand the poisonous effects of the carbon monoxide. Now we are going to focus the effects of the other pollutants, specifically the sulfur dioxide and oxides of the nitrogen. You can see the effects of these poisonous gases. Irritates the eyes and the lungs and cause the breathing difficulties in humans and other living organisms, specifically animals. High levels lead to inflammation of the lungs, and very important, they react with the water in the atmosphere to form acid rain, which corrodes buildings and harm aquatic life. This is the diagram to represent how these gases are converted into the acid rain. And the effects on the human body. So these are the effects of these pollutants. Now we are going to focus on our homework. I have selected these two questions for your homework. The question number 1, discuss in detail the fractional distillation of liquid air, and second question is discuss the redox reactions in the catalytic converters. These are present on the page. Question number 1 is on the page number 306, and the question number 2 is on the page number 309. Dear students, thank you very much for being with me. Hopefully you have understand your today's topic. Please do your homework and send to your respective groups. And my second request to you, please stay at home, stay safe. Allah Hafiz.